Okay, so I know that I'm not going to see some of you guys for a little bit, so I wanted to make a quick video going over the 2.1 to 2.5 review that we did in class. I know that most of this you guys should have down, but there's a few places where you might have gotten lost on something, so I will try to be a little more thorough in my explanation. But each of these videos should be less than 10 minutes. So let's take a look at our first problem here. So there's a couple of ways that you can solve for the vertex of a problem. One of those ways is you could use that x is opposite b over 2a version, which we actually did earlier in this year, which would be the opposite of b would be positive 8. 2a's would be 6, which would give me x equals 4/3, which is actually the equation for the axis of symmetry. Now, if I were to go back into this original problem and plug in 4/3, 3 times 4/3 squared minus 8 times 4/3 plus 7, that is a little bit kind of a booger, but let's see, that'd be 16/9. 32/3 plus 7. It looks to me like this is 16 over 3 because 3 and 9 cancel. And instead of calling that 7, I'm going to call it 21/3. It's kind of a lot of work right there. So if I put all that together, 16 and 21 is 37/3 minus 32 is 5/3. So it looks to me like when I got all that done, I plugged 4/3 in, I got 5/3 out, which means I could write this problem in vertex form, noticing that it had a leading coefficient of 3. And it got slid over to a vertex of 4/3, comma 5/3. Now, we could have done that using completing the square. And the process that I had you go through is you factored the 3 out of the x terms. So that's going to leave us with an x squared and a negative 8/3 x. And I know that's a little bit uncomfortable because we don't like fractions like that, but it's not that big of a deal. Then we need to go ahead and complete the square because this is technically not a completed square yet. So on the next step, what we do is we take this piece right here, which was negative 8/3, and we cut it in half, and we square it. Now, at this moment in time, we've actually kind of messed our problem up a little bit because this 16/9 was not actually part of the question. So I need to balance it. I've actually added 16/3 if you distribute the 3. I've added 16/3. So what I need to do is take 16/3 away because these two things then, according to just how the math plays out, would actually cancel each other out. 16/3 minus 16/3, that means I really haven't done anything. And that leads with our final answer of x minus 4/3. Now, some people get confused about the 4/3, but it came from the number that we got when we cut it in half. And then if we took 21/3, like we saw over here, and subtract 16/3, we get 5/3, which I suppose if we had wanted to, we could have started with this side and we could have had the answer for the vertex and the axis of symmetry, and we already had this done. So the completing the square version is a pretty efficient version of finding that data. Now, when we go to the next problem, what we're going to do is we're going to go ahead and try to, let me see if I can make the screen a little bit bigger. I'm going to try to use graphing by transformation techniques. And one of those techniques we said is never let anything be attached directly to x. And so that would mean that we would want to take all of the y values and multiply them by -2. So since a is -4, -2, and I multiply all the y values by -2, it's going to make that y value 4. Since -2 comma 0 is the b value, that means I'm going to multiply 0 by -2. And last, when I take the c, which was 7 comma +3, it's going to turn into 6. Now, the last thing is the x values, remember, are living in the land of disagreement. Everything does the opposite of what it says. So that means we're going to divide all the x values by 2 and then subtract 3. So -4 divided is going to be -2, and then I go backwards 3, and I'm at -5. I take -2 and I divide it, and I get -1, and then I go backwards 3 and I get -4. And last, 7 cut in half is 3.5, and I take away 3 and I get 1/2. And that literally, oh, I think I made a mistake right here. That was a -6, wasn't it? Okay. Now, in number 3, there's a couple of things that kind of mess with people's head. Is it says, let's find the cubic equation from this table. But what's interesting about it is it doesn't have to be that hard, because as soon as we know we have a root at x equals 3, that means we have a factor of x minus 3, because our factor theorem said those things go together. Secondly, we know that if we have a root at -2, that means we have a factor of x plus 2. And then last over here, we know we have a root at -1, which means we have a factor of x plus 1. Sorry, kind of putting a lot of colors on there to kind of show you where they come from. Now, the only thing that's going to really kind of mess us up is sometimes we have a leading coefficient right here that might be some value like this. Now, I've ignored the number 5 and 21 because that's not a root. We don't have a special theorem for that, but this says that if I plug in 5 for x, 5 minus 3 is 2, 5 plus 2 is 7, and 5 plus 1 is 6, that the answer for y is 21. Well, if you do just a little quick arithmetic, we would find out that a has to be exactly 1/4. So my final answer is 1/4 x minus 3, x plus 2, and x plus 1. And that should actually generate this beautiful little table that we have right here. Now, the last question for this first video is question number 4. That you have a friend that's looking through this problem, and they claimed the following answers, and I wanted to come up with a couple, and I mean, honestly, 2 would be pretty good, but 3 is even stronger. And the first thing that I notice is that -3/4 is not a good root. That is impossible. And I know that it is impossible because when we look at our possible rational roots, the numbers that go into 24 are all good. 1, 2, 3, 4, 6, 12, and 24. These are good numbers, but the denominators have to come out of this 6, and that's not possible because 4 is not a factor of 6. That's all I needed to know. That's not even a possible answer. Now, there may be other ways, but I personally looked at Descartes' rule of signs. And right away, what I noticed is when I counted, I saw 1 sign change here and 1 sign change here. So there should be 2 or 0 positive real roots. Now, that doesn't mean nice roots, but just means positive real roots. And this person claimed that there was exactly 1 positive root, which is not even a possibility. The last thing I did, which is really borrowing from the same thing, is that if I looked at f of -x, I got a negative here. A negative cubed is negative. A negative squared is positive times that is negative. A negative times a negative is a positive, and that's a 24 is a positive. I see 1 sign change, so Descartes would have said 1 negative real root. And again, if you look at the answer, they only had 2 negative roots. Now, one of the things that we can also do, keeping in mind that you won't be allowed to use Desmos on your test, but it is nice when you're actually working on homework and whatnot to actually think back to that. So I actually did look at Desmos and figured out that I typed this into the original equation right here, and I typed that in, and I found out that they were laying on top of each other. Also on this problem, I typed this in. In fact, you could do this on your graphing calculator. It's pretty easy to do. Is we can type in 1/4 x minus 3, and it is worth noting that I know a lot of students started multiplying this problem out, but it never specifies that it has to be in standard form. So what I'm going to do is I'm going to look over here at my table, and according to this, if I plug in 3, I'm supposed to get 0. If I plug in, excuse me, -2, I'm supposed to get 0. 5 is supposed to be 21, and -1 is 0. So it appears that I did a pretty good job. And I think that should kind of polish us up for our first video. And it's going to pause for a moment because for some reason my screen went to the wrong side. So I'm going to end this video here, but you're going to see me messing around with my computer for a few moments to get control of my screen again. And so that's where we are, and I hope that was helpful. I'll be back with the next video.